Imagine looking up at the night sky and seeing a star suddenly become brighter than an entire galaxy, visible from millions of light-years away. For a few weeks, one dying star can outshine billions of others before fading forever. This incredible event is called a supernova, one of the most violent and spectacular explosions in the universe. But what causes a star to explode? Why are supernovas so important? And could one ever happen close enough to Earth to affect us? Let's find out. A supernova is the explosive death of a star. For most of its life, a star is locked in a constant battle. Gravity tries to pull all the star's matter inward, crushing it. At the same time, nuclear fusion in the core produces enormous pressure that pushes outward. As long as these forces stay balanced, the star remains stable for millions, or even billions, of years. But eventually, every star runs out of fuel. When that balance is broken, the result can be one of the brightest explosions in the universe, a supernova. In just a few seconds, a supernova releases more energy than our Sun will produce during its entire 10 billion-year lifetime. Not all supernovas happen the same way. There are two main types. The first is called a core collapse supernova. This happens to massive stars, usually at least 8 times heavier than our Sun. These stars fuse heavier and heavier elements inside their cores. Eventually, they create iron. The problem is that iron doesn't release energy through fusion. Without energy pushing outward, gravity suddenly wins. The core collapses in less than a second. Temperatures reach billions of degrees. The collapsing core rebounds, creating a shockwave that tears the star apart. The explosion throws enormous amounts of gas and newly created elements into space. Sometimes, what's left behind is a neutron star. If the original star was massive enough, the core continues collapsing into a black hole. The second type is called a type Ia supernova. This begins with a white dwarf, the dense remains of a sun-like star. If the white dwarf has a nearby companion star, it can steal gas from it. As its mass increases, it eventually reaches a critical limit. The pressure becomes so extreme that carbon fusion starts almost instantly throughout the star. The entire white dwarf explodes, leaving almost nothing behind. Unlike core collapse supernovas, these explosions are remarkably consistent in brightness. Astronomers use them as standard candles to measure enormous distances across the universe. Supernovas are much more than spectacular explosions. They're responsible for creating many of the elements that make life possible. The oxygen you breathe. The calcium in your bones. The iron in your blood. The gold in jewelry. Even the uranium used in nuclear reactors. Many of these elements are created inside massive stars or during the supernova explosion itself. Without supernovas, planets like Earth would never have formed. In a very real sense, we are made of stardust. Supernovas also spread these elements across galaxies. Eventually, that material forms new stars, new planets, and perhaps even new life. Every generation of stars enriches the universe a little more. The idea sounds terrifying. Could a nearby supernova wipe out life on Earth? The answer is yes, but only if it happened extremely close. Scientists estimate that a supernova would need to occur within roughly 30 to 50 light-years to cause serious damage. Its radiation could strip away Earth's ozone layer, exposing life to dangerous ultraviolet radiation. Fortunately, no known star close enough is expected to explode anytime soon. One famous candidate is Betelgeuse, the giant red star in the constellation Orion. It will eventually become a supernova, but it's around 550 light-years away. When it finally explodes, it could become bright enough to see during the daytime. It would be an incredible sight, but completely safe for Earth. Every supernova marks the end of one star's life. But it also marks the beginning of something new. The explosion scatters the ingredients needed to create future stars, planets, and life itself. Without these cosmic explosions, our world, and even we ourselves, might never have existed. The next time you look at the stars, remember, Every atom inside your body was forged in the heart of ancient stars, and many were scattered across space by the unimaginable power of a supernova. We are, quite literally, the children of exploding stars. If you enjoyed this journey through the universe, don't forget to like the video, subscribe, and join us for more fascinating science and mysteries of the cosmos. Thanks for watching.